I told you each day we would be working on a different transformation. Today we're going to be working on translations. Translations, kind of a big word, but what it means is when you like slide a shape to a new position. So for example, if you have like a right triangle and then you slide it to a new location, that would be a translation. So when we do a translation, it's not turning the shape, it's not flipping the shape, it's in the same like direction and orientation, it's just in a new location. So a translation moves the shape up, down, right, or left. When the figure has been translated, it will still be facing the same direction. Again, not rotated or anything like that, or flipped, nothing like that. And then what we're going to be looking at today is like the directions, so like mathematical directions to tell somebody exactly where that location is. And that's what we're going to be looking at. So how do you know how much to move it and in what direction? A translation vector can be used to describe the direction and distance of the translation. So the vector can look different ways. So the first way we're going to see it is like visually. So it says the translation of the figure along the translation vector. This right here is a translation vector. It's saying that we need to move this shape in this direction, this distance. So when we translate a shape, just like with reflections, we're just going to move each point, that distance, that direction. So we're going to move point C like this. So I'm trying to make that same vector, same direction, about that distance, point B and point A. So I just drew this vector from each of these points, and then I would have point A prime, B prime, and C prime. And then you connect your dots, and then you have your translated shape. Okay, so that would be visually exactly what we're doing, but what about with numbers? How will this look with numbers? Okay, so just like before, we're going to work with just one point, and then we're going to work with shapes after we can kind of get the hang of it and know all the rules. I'm going to zoom out a little bit because not all fitting. Okay, so here it says graph our original point A at -3, 2, and then A prime is at 3, -3. So A, -3, 2. So here's point A. And then A prime is at 3, -3. A prime. Okay, so this is the original, this is the new one. Describe the movement from point A to A. So imagine it's like slid. Describe the movement. I would say like down and to the right, like kind of diagonal. But that's just not precise. So the way we get like a precise direction is we say, okay, to the right, however many units, and then down, however many units. So we're moving this point to the right, 1, 2, 3, 4, 5, 6. So right 6 units, and down 1, 2, 3, 4, 5 units. Down 5. So describe the movement, right 6, down 5. Okay, and then it says translation vector again. So remember, translation vector was like this, like a direction. But how do we make this with numbers? So we're going to use this symbol here. And to the right 6, that would be plus 6, because it's going plus 6 on the coordinate plane. And then down 5 would be minus 5, because like minus 5 on the coordinate plane. So our vector looks like this, positive 6, negative 5. And this means right 6, down 5. So this goes with your x coordinate, which makes sense because you're moving it right or left. And then this goes with your y coordinate, which makes sense because you're moving up or down. And then you can use these vectors with the points. So instead of like counting to the right 6, down 5, you can also like add these numbers to the coordinates. So -3, 2 is our original. We can say, okay, plus 6 minus 5 to the y coordinate. And we'd get 3, -3, which is this number here. So negative 3 plus 6 is 3. 2 minus 5, negative 3. Okay, so again, just talking about different formats and different ways they explain this. So the rule now is that xy is x plus 6, y minus 5. It's what it gave me here. Yeah. Okay, so then this is my translation rule, and this means to the right 6, down 5. So sometimes they'll use an abbreviation, x plus h. H stands for horizontal change. Y plus k is vertical. So x plus horizontal change, y plus vertical change. Are you guys good with horizontal versus vertical? I used to always mess that up when I was a kid. If you have trouble with horizontal, the one thing that stuck with me would be like the horizon. The horizon, the water line is horizontal, so horizon is horizontal. And then vertical would just be vertical. Okay, and then these are just to kind of like check to make sure you understand the concept. It has a translation rule right here. It says x plus 2, y minus 5. X plus 2 would be to the right 2, and then y minus 5 would be down 5. So 2 units to the right and 5 units down. And here, what is the algebraic description for a transformation that translates the point 2 units to the left and 3 units up? So 2 units to the left would be minus 2, and then 3 units up would be plus 3. So the translation rule would look like this. xy would be x minus 2, y plus 3. And then once you're done with that, we'll flip to the next page, and then we're working with whole shapes. Okay, so here it says that we have a trapezoid, JKLM, with these vertices, and the vector is negative 7, negative 3. So that would be left 7, down 3. So we're going to plot or graph our original points for the trapezoid, and then we're going to translate them left 7, down 3. So first things first, I'm just going to graph my original points. So the pre-image, J is at 2, 4. A 1, 1. L 5, 1. M 4, 4. And connect the dots. Okay, and then the vector is negative 7, negative 3. So for each point, I'm going to move it to the left 7, down 3. So J, I'm just going to count 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, right here. So this would be J prime. And I'm going to do that for each point. 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3. I get M prime. You can also use the coordinates if you don't want to count from 1 to negative 6 would be 7, down 1, 2, 3. 5, negative 2, 1, 2, 3. Okay, so then here is our image after the translation. In addition to graphing and like counting squares to find the new shape location, you can also use math. So what I'm going to do here is write down all the original coordinates. So J is at 2, 4, K was 1, 1, L is 5, 1, and m is 4, 4. And then you can use the vector and just add this to the x-coordinate and add this to the y. So 2 minus 7 minus 3. And then I can use math to find the same coordinates that I graphed. So 2 minus 7 would be 5. 4 minus 3 is 1. Negative 6, negative 2, negative 2, negative 2, negative 3, 1. So I just use math. I just use math to find these points, and then I'm just going to make sure that those are the ones I graphed. 5, 1, negative 6, negative 2, negative 2, and then negative 3, 1. Cool. So it works. Okay. And then the next one, I'm going to do that same thing. It gives me a triangle with these coordinates. The vector is negative 1, negative 2. So that would be left 1, down 2. So I'm going to graph the original again. 2, 5, Q, 7, 1, R, and S, negative 1, 2. So here is my triangle. And then, because of the vector instructions, I'm going to move each point to left 1, down 2. Get Q prime, S prime, R prime, and then connect the dots. And this is my new translated shape. Then I'm also going to find these coordinates using math. So 2, 5 is my original, 7, 1, negative 1, 2. And then the vector is negative 1, negative 2, so minus 1 on the x, minus 2 on the y. And then calculate this out. And then make sure that those are the same points that I got too. So like 1, 3, yep. 6, negative 1, yes, negative 2, 0. Cool. Okay, and then the last one here is more like standardized test practice. You know, they always like to present it in kind of like a different, weirder way. Here it says AP, this segment undergoes a translation, and A prime and P prime land at this location. So A prime is at 1, 1, and P is at 4, 3. Cool. P prime. So it says in there those points. So this is translated to here. What are the values of H and K? Remember, H is horizontal change, and K is vertical change. So obviously the copy is not great, so it's hard to see how it's changing. So I'm going to be looking for how P gets to P prime. So it goes to the right a certain amount of units and then down a certain amount of units, and you can't, it's hard to see because of the copy, but it's to the right 8, so like plus 8, and then it goes down 5. So the horizontal change is positive 8, the vertical change is negative 5. And then the questions, again, anytime they have multiple choice or anything, they're just looking for you to understand that this segment is the same, like it's congruent to this, it's in the same direction and everything. So it says, which of the following statements is true? AP and AP prime have different locations. That is true, that's probably my correct answer. AP and AP prime have different shapes. No, they're the exact same shape. Different sizes? No, they're the exact same size. Different directions? No, they're pointing in the same direction. So the answer is A here. And there's one more type of problem that might show up on your homework that I want to make you aware of. So for the one that might show up on the homework, there's like two parallel lines like this. and it says, okay, a shape, like a right triangle, is reflected twice over these parallel lines. So it'll say reflection over parallel lines 2 times. And I want to know like what other transformation that could be. So if we reflect this over the parallel lines once, we'd get this. If we reflect it over the second one, because it says reflected twice, we'd get this. And that would be the same as translating this here. So the answer is results in a translation. So kind of a weird question. So if you get that one, that's how you do that. Okay, that is all. You have the rest of class to work on your homework. So grab a laptop, do the Schoology homework first, and then work on Alex after that.